So hi and a very good day to Dr. Maski. So my name is Chang, Roman Crypt 3124, and today I'm going to present my assignment 1 titled CINETRACK, which is a client-to-server data synchronization system. So now let's begin with the objective and the scope. The core mission of my assignment is to deeply understand and master the complete data flow of my system, starting from the client brochure all the way to a backend relational database. Instead of just rely on the shortcut or modern framework, this project challenged us to build the entire SQL synchronization process from the scratch. By doing this, I established a persistent source of truth for the data and proving a solid mastery of vanilla JavaScript, PHP, and MySQL working perfectly together. So in order to achieve this objective, I utilized the modern web tech stack shown here. For the front end, I structured the application using HTML5 symmetric elements and designed a custom dark cinema user interface with CSS. And then for the logic layer, I strictly use vanilla JavaScript to handle form interception, local storage buffering, and the fetch API communication. Finally, for the backend, I use the procedural PHP to process the incoming data streams and connect it to a MySQL database that run on my local port for the permanent storage. Okay, now let's moving on to the phase 1, which is focused on the client-side input capturing. When a user submit the movie form, the application will immediately intercept the default form submission event using the JavaScript. This step will prevent the browser from trigger a full page reload to ensure a highly responsive and a modern user experience. The system then will securely capture all 7 required inputs from the form control and preparing them to be temporarily buffered before transmission. For example, on this source code, I group all the 7 distinct user inputs. For example, like the movie title, streaming platform, rating scale, and the watch date into a structured JavaScript object named record. To satisfy the requirement for the local data persistence, we use the JSON3025 method on this object into a standardized JSON string format. Finally, we invoke the local storage setItem method to store this payload in the browser temporary storage buffer to complete our client-side caching closed loop. Next, for the phase 2, which handles the server-side processing, once our fetch successfully delivered the payload to the backend, my API.php script will take the full control. The responsibility is to read the incoming network data stream, interpret the structure, and open a secure gate to our relational database management system and accurately execute the data persistence operations. Okay, so now let's see the source code. In the backend script, we fetch the raw data stream using the PHP inputs. Since the payload arrives as an serialized text log, we apply JSON decode method with the associative array flag set to true and transform it to the string back into a native PHP associative array. For the database connectivity, I established a stable handshake through the procedural MySQL connect method function to specify the target on my local server environment configuration and to run on my port. Next is the phase 3, which acts as a critical bridge connecting to our client-side interface to the server-side database. Instead of just making a traditional HTTP request that causes a disruptive wide spring reload, I execute an asynchronous synchronization process. The fetch API will operate the entire in the background, serve as a reliable courier that safely transports our cache payload from the browser storage over the web server without interrupt the current user interface. Okay, so here is how the fetch API bridge is implemented in the code. I initiate a background fetch request configured with the HTTP post method. So why did I choose the post method instead of get here? Because post will secure our raw JSON payload inside the HTTP request body. This will ensure that the sensitive user entries are completely hidden from the browser URL address bar. Once receiving a success response from the server, the system will trigger a local storage.removeItem method to instantly clear the temporary cache and completing a highly efficient data synchronization life cycle. Now let's discuss about the database insertion strategy and security. To strictly follow the assignment guidelines, I have constructed the SQL query using the standard string concatenation. However, if a user inputs a single code, for example, in a movie review, it will break the SQL syntax and crash the query. To solve this and prove the mastery of security, I have applied the MySQL real escape string method to all the text inputs. Why? Because if a user types a single quote in their review, it will break the SQL string and crash the database. This function will sanitize the input to prevent further syntax errors. Next is the UI/UX concept of CINETRACK for its visual appeal, custom controls, and feedback. To simply explain this, I have designed a dark cinema themes. Beyond aesthetics, I have focused on the responsive feedback too by implementing the modern toast notification and dynamic button states to ensure the user always knows when the data is being synchronized. So as shown in the code here, I didn't use the basic text fields. Instead, I implemented the HTML5 specific inputs like input type, date, and the select dropdown. This will ensure a better data integrity and a more contemporary user experience. Here is the visual result. The custom range slider for the ratings and the modern date picker provide an intuitive interface that aligns perfectly with the cinema themes. To summarize the technical why behind my logic, I choose host to keep sensitive payloads securely in the HTTP body, and I use JSON parsing because it will provide a consistent data structure to bridge the gap between the JavaScript object and PHP associative arrays. Now let's move to the live demo section for CINETRACK. First, I will load a movie or a show at the Add Entry section. For example, I choose the anime Attack of Titan, select or input its details with a perfect 10 rating, and then leave a quick review. Watch closely when I click Save. The JavaScript will intercept the form, buffers the data in local storage, and instantly send it to the PHP backend through the Fetch API. As you can see, the form clears automatically without reload the page. To show how seamless this asynchronous flow is, let me quickly add a second movie too. For example, open Humor with a short note and its details. After that, hit Save. So you may notice that there is a green toast notification at the bottom right and the immediate form reset. The user experience is now smooth because the browser never freezes or reloads. Next, I will switch to the My Watch list tab. The system dynamically fetches all the records using a GET request. Look at the colorful status match. Now, I will use the real-time search box. As I type the title, for example Titan, or the platform like Cinema, YouTube, and so on, the table will filter instantly. This proves that the data is safely persisted in the MySQL database and retrieved asynchronously. Finally, let's test the delete function. For example, I will remove Interstellar from the list. I click Remove and Confirm. A delete request is sent to the server, and the row is erased from the interface immediately without refreshing. This completes our full CRUD data lifecycle. So that's all from me. Thank you.